Okay, so our next lesson, number 88 in numbers of operations, estimate square roots. So let's estimate. Okay, you can always pause the video and read through the objective and the things. So here's a chart of perfect squares out to 1 to 30. And these are numbers that you should memorize if you're in the 8th grade. Let's break it at 8th grade. At the end of your 8th grade year or the beginning of your 8th grade year, you should have memorized your perfect squares up to 15. And by the end of your 9th grade year, you should probably know them out to 30. Because these numbers are used a lot in a lot of problems, especially when it comes to science. You'll be dealing with perfect squares. All right, here's some rules and notes for you. Okay, so what we're going to do is estimate the square root. So what you need around the square root is the low number and the high number. The low number perfect square and a high number perfect square. So let's think about our perfect squares around 7. So the square root of 9 is 3, and the square root of 4 is 2. So the square root of 7 is somewhere in between 4 and 9. Okay? And we're not dealing with the number yet. You just got to deal with the square root part. So let's deal with the numbers. 4, 5, 6, 7, 8, and 9. So halfway between 4 and 9 is 6.5. Because we can see 5, 6 is to the right of 4, and 8 and 7 are to the left of 9. So halfway in between 6 and 7 is 6.5. 7 is actually closer to 9. It's just beyond the halfway point, but it's actually closer to 9. So we're going to say that the square root of 7 is a little bit above 2.5. So we're going to call it 2.6. So we put our 2.6 right on the line, and the square root of 7 is here, the square root of 9 is there, and the square root of 4 is there. And that's all we're doing. We're just estimating. We're just getting a good guess of where the square root is going to be. You don't need to get exact with it. You just need to get close. You need to understand the low square root and the high square root around a number. Okay, so let's look at our second example here. The square root of 115. So how do we estimate the square root of 115? And again, we don't need a precise number. We just need the best guess. So the low number is the square root of 100, which equals 10. And then the square root of 121 is the next one above 115, which is the square root of 11. So now you use your perfect squares to do your estimation. So 115, is it closer to 100 or is it closer to 121? Well, 115 is 15 away from 100 if we subtract the numbers. And if we subtract the numbers going this way, 121 minus 115 is only 6 away. So this one, the difference from 115 to 110 is 15. The difference between 121 and 115 is only 6. So we're going to estimate the square root to be closer to 11. How much closer? It doesn't matter. All it matters is that it is bigger than 10.5. It's in between 10.5 and 11. So, it's only 6 away. And you could put 10.6, you could put 10.7, you could put 10.8, and you'll be close. This is just for estimation purposes, and all you need to know is that the square root of 115 is bigger than 10.5 and smaller than 11. So I picked the number 10.7, and we will put it on the number line on the next slide. So we know that, okay, so from the previous page, we estimated that the square root of 115 was bigger than 10.5 and smaller than 11. So 10 is all the way at the end of our screen. So the square root of 100 equals 10. So we don't have room. So I should have made a bigger number line for us. The square root of 100, not 100. The square root of 115 is bigger than 10.5, but smaller than 11, because the square root of 121 equals 11. So that is this example. Okay, so these were the end of our examples, and I will see you at the end of the video for the recap. Okay, so you had the square root of 42. And the square root of 42 was the closest one, was the square root of 36 and the square root of 49, which is 7. The square root of 36 is 6. 42 is 7 away, 7 numbers away from 49, and is 6 numbers away from 36. So it's actually closer to 36, which means that it's less than 6.5, because it's not in the middle. 42.5 would be in the middle. So we'll estimate this at 6.4, because it's very close to the middle. So the square root of 36 is here. The square root of 49 is here. And the halfway point, and we're going to be just a little bit of the halfway point at 6.4, and the square root of 42. And this is how it fits in. Let's look at the problem. So estimate the square root of 300. So what do we know? We have to look on our multiplication charts or our square root charts. And we know that the square root of 289 is under 300, which is 17. And then what's to the right of 300? 324 is the next one. And the square root of 324 is 18. Okay, so 324 minus 300 is 24. 300 minus 289 is what? 21. So the square root of 300 is actually closer to the square root of 289. And so what I'm going to do is take our number line, and I'm going to put ones in front of every number because we can use this number line. And so if 300 is closer to 289, then it's less than 17.5. And so we're just going to call it 17.4. And so we put the square root of 300 in between the square root of 289 and the square root of 324. So it's in this range. It's in a range of 17 to 17.5. Now we could have calculated out the halfway point and done some things, but all of that is not necessary. There are other ways to solve these problems by finding what's exactly halfway between 289 and 324 and then going from there. But I find it just easier just to say, is it closer to the one to the right or above it, or the one to the left or below it? And then just see which one is closer to, and then just put it on the other side of the halfway mark. I find that easier. If you don't find that easier, what you can do is actually say 324 minus 289. You will subtract these numbers. 14 minus 9 is 5. 31 minus 28 is 3. Then you had to divide them by 2. And you would get 17.5. You would add 17.5 to 289, which is 6. 306.5 is actually the halfway point. And then you see that 300 is less than 306.5, which is the square root of 306.5 should get you to 17.5 or close enough to it. And then since 300 is less than that, then it's on the left side and it's in this range. You still get the same thing, but it's just a lot more math. I find it far easier, again, to take the root, the perfect square above your non-perfect square, your non-perfect number, and the root below it, the perfect square below your non-perfect number, and just see which one is closest to by subtracting, and then whichever one is closest to, and you just know it's in the range of bigger than the halfway point in that number or smaller than the halfway point in that number. So I hope that was clear. I hope that you had good practice with your squares and square roots. Please watch all of these videos in a series because I may have gone a little quickly, and you probably had to go back and maybe had to go back and watch a couple of these videos again. So thank you for your time. Again, please subscribe to this channel for more videos coming up. Thank you.